Hi there, and thank you for clicking on this video. In this lesson, we are going to take a look at solving equations using logarithms. Now, I do want to be really honest with everybody right out of the gate that there are a lot of different ways that you can weave your way through this material with your exponentials, your logs, your properties of logs, log equations, all of that. And so if we get into this video and you realize that what I am covering in this lesson does not quite align with what you're looking for, it could be that your teacher is just moving through the material in a slightly different way. Try checking out one of the videos that comes before this one or one of the videos that comes after this one in the playlist to see if that lines up a little bit better. But there's obviously I've got to commit to a way of doing this. Please give this video a thumbs up if you find it helpful, subscribe for more math content, and comment to let me know what you think. And most importantly, check out the practice set for this lesson to test to see if you are understanding what we are covering and you are able to do it on your own. Now, this lesson, I wanted to start out with a review of what we've already covered, just to make sure that we're all on the same page here. So solving exponential equations using like bases. We've already looked at this in a previous lesson. So if you're looking for that content, like if you're looking at that problem on the left there and thinking, that's what I want, I will link that in the description box so you can click right over to that lesson. But if you have 4 to the 2x equals 8 to the x plus 2, what we would try to do is get the same base on both sides. And so we might try the 4 first and say, okay, 4 to the first power is 4, 4 squared is 16, and we've obviously jumped over the 8. Okay, there wasn't a power of 4 that would give us 8. And so we would go for a smaller base and we'd say, well, maybe a 2 would work. 2 to the first power is 2, 2 squared is 4, so we got that, and 2 to the third is 8, and there we have it. And what we do is we take out the 4 and we replace the 4 with a 2 squared. Now, in the original lesson, I use an analogy called the super cool exponent club, where we look at that original exponent and say, okay, they are the super cool club, and now they have a newcomer that wants to come in to the exponent, and they don't accept the newcomer. Okay, they're like snobby, and so they put up their exponent walls. Now, in that particular one, the parentheses are not necessarily needed, but they will be needed over here, where we're going to take out the 8 and replace the 8 with a 2 to the third power. And so now my existing exponent was the x plus 2, and I do need the parentheses. What they do is preserve the order of operations with what was already being done, which needs to be done first before you do like the new thing. Once we have the same base on both sides, we have 2 to the something equals 2 to the something. My two somethings must be equal to each other. And I do not typically do this when I'm presenting, but I would do that multiplication as I'm copying it down. So the step that I just wrote, I would not normally write that. I would say 2 times 2x is 4x, and I would go ahead and do that distribution as I was in the process of rewriting it. Now we've got a linear equation, so I will subtract 3x from both sides. 4x minus 3x is just x. 3x minus 3x is 0, leaving me with just the 6. Okay, now that is the strategy that we have already covered. Now, in a previous lesson, we also covered how logs undo exponentials. So in that expression right there, I have 3 to the x power. And the drawback to that is that the x is stuck up there in the exponent. And I would like a way of undoing that base. Well, up until you're studying exponentials and logs, there's no tool in the toolkit that can undo that. That is a 3 multiplied in as a factor some x number of times, but without any idea of how many times it has been multiplied in, I don't know what to divide by. So that does not help me. So we introduced this new operator called a logarithm, and that logarithm can have a base that indicates what it undoes. And this log base 3 undoes this base of 3, leaving me with just an x, okay? And so the log undoes the exponential, and that is explored in a lot of detail in my lesson where I introduce what logs are. And so we want to have that well-grounded heading into this lesson and this problem set. So what about an equation like this? So now I've got 3 to the 2x is equal to 4. And I cannot use that first strategy because I cannot write 4 as a power of 3, and I cannot look for a smaller number since 3 is already prime. So 3 to the first power is 3, 3 squared is 9, and I'm looking for something that is going to give me a 4. So in a situation like this, where you can't write the two sides of the equation as powers of the same base, this is when we're going to invoke a logarithm. And so the base that I need to undo with this log is the base of 3. And that indicates to me which kind of a log I am going to engage in this problem. So to undo a base of 3, we are going to do log base 3, and I'm going to do log base 3 of 3 to the 2x. Now, the golden rule of algebra says whatever you do to the left side of the equation, you must do to the right. This is like a balance scale here where I've got a 3 to the 2x on one side and I have a 4 on the other side. So if I'm going to come over here and do log base 3 of that side, I have got to do log base 3 of the other side. Otherwise, this is no longer a balanced equation. So we will have log base 3 of 4. On the right-hand side, log base 3 will undo the base of 3 on the exponential, leaving me with 2x. Now, right here is where I will often tell my students, okay, go ahead and change that over to a decimal. But in this lesson, I want to get a little bit more nuanced. So I have 2 times x is equal to this lovely expression with a log in it. And if I want to undo the multiplication, I would divide. And so this expression right here, log base 3 of 4 divided by 2, is what's called the exact answer, meaning that we have it's like something with no rounding in it. My apologies. Something with no rounding in it, and that would be the exact answer, just like that. Now you might be saying, well, isn't 4 divided by 2 2? Well, yes, 4 divided by 2 is 2, but remember that that's not a 4. It's log base 3 of 4, so it is some other number there that we would need to use a calculator to figure out what it is. And so we don't want to go and do the division. So that comes back to order of operations. Does it matter what you do first? Do you do the log first and then divide, or can you divide and then take the log? And so that we could explore that with like specific numbers. But like, I mean, I'll just tell you, like, you got to do the log first. So the log was being done first, and then we would be dividing by 2. Now, to evaluate that, I'm going to put a link up here, okay, for evaluating. If you are not sure how to use a calculator to evaluate that log, be sure to click on that link right there, okay, for a quick, like less than 3-minute tutorial on how to do that. I'm going to be doing it on my calculator here. So I have log of 4 divided by log of 3. So this is, I'm going to change my color back. So that ends up being 1.262 divided by 2. And so divided by 2, and I get 0.631. Okay. And when it comes to rounding, I usually tell my students that 3 or 4 decimal places is pretty standard operation, for rounding, but always read the directions for whatever you're doing. But like 3 or 4, unless you are told something specific otherwise. All right, let's go take a peek at the next one. So this one is introducing 2 nuanced things. One is that this strategy works for bases other than integer bases. So we have 4.5 equals 3.2 to the x power. The other thing it does is it switches the position. And like in math, the position of something is not usually the important thing. So like whether something's on the right, the left, what matters in math is the operational function. So is this number dividing? Is it being multiplied? Is it being added? Not is it on the right side of the equation or the left side of the equation? But a lot of students tend to think that that's like a really, really important thing, like whether something's on the left or on the right. So I wanted to make sure that I got one in here that showed the exponential on the right. Now, this one, we don't even know what our powers of 3.2 are. So we're going to go straight to, I am going to do log base 3.2 of 3.2 to the x, because the log base 3.2 will undo the base of 3.2 and will leave me with the x. But as I mentioned on the previous slide, whatever you do to one side of the equation, you must do to the other. So we have this lovely balanced equation here. And so if I come along and say, all right, I'm going to take log base 3.2 of the right, I need to make sure I am taking log base 3.2 on the left as well. And so we'd have log base 3.2 of 4.5, and then we will run that into the calculator. So log 5 divided by, I am using a calculator I do not normally use. So 1.293. There we go. And if you were asked for the exact answer would be this, log base 3.2 of 4.5. So you just would not do the step where you're doing the rounding. Just leave the step out where you're rounding stuff off and call it a day. Okay, next up is this. So take care to isolate the exponential first. We have seen this principle at work before if you followed all of my lessons, and hopefully if you haven't done that, you've seen it in your math classes, where if you're solving something, there's often an isolation step before you can undo a particular thing, let's say a square root or a cube root or something. Exponentials are the same way. So we got the wrong way and the correct way. So the wrong way of doing this would be to look at the equation and say, well, that is a base 3 exponential. Therefore, I am going to do log base 3 of both sides. Okay, seems like a good idea until you get right here. Okay, so if you have your perfectly balanced equation, right? And you take the log base 3 of the entire right-hand side, you cannot do a partial log base 3 on the other side. So you can't do log base 3 and then only do the 3 to the x plus 3 and not touch the 5 at all. Like that won't work. So you might say, okay, well now that's x plus 3 minus 5 must be equal to log base 3 of 6, except we never did anything with the minus 5. So on the right hand side, we had this total log of like the whole thing, and on the left hand side we only logged some of it. Well, that's not balanced anymore. So you might say, okay, well, fair enough. I could fix that if I did this. I just took the log of the whole thing and then wrote this to say, okay, well, then I'm going to subtract that. And here's why that's not an okay thing to do either, okay? Now, your reasoning in doing that is not bad reasoning. So if you're thinking, well, that seems like a good idea, what am I missing? You're not really missing anything. It is a logical idea. It just doesn't work because of this pesky thing, okay? Order of operations. This is not a multiplication step, okay? And so I'm going to put that there. This is not multiplication. So if you were thinking, well, can't we multiplication? Okay. If you were thinking, well, why can't I distribute taking the log through? Because order of operations dictates that that does not work. Distribution is when you distribute multiplication over adding or subtracting. And there's a couple other things that we do in math that look like distribution, but we've really got to be sensitive to what is happening. And so we had a x plus 3 with the base of 3. But the 5 is not being touched. And so when you go to undo the exponential here, we actually don't want to split it up that way because taking the log of two things is not the same as the log of the subtraction. It's coming up in a future lesson. It basically does not work. So that leaves you with this question. Okay, well, if neither of those things works, because we have order of operations issues, because we're not logging the whole side, then what should we do? Well, let's just get rid of the 5. Okay, the 5 is the thing that's causing the issue, whether it's not taking the log of it or taking the log of it in the wrong order, or that's the problem. So what if we just did this and added the 5 to both sides, since it was never part of the exponential in the first place? Now I don't have to worry about this. Now I can go ahead and do log base 3 of 3 to the x plus 3 and log base 3 of 11, and we are good to go on that one. On the left, the log base 3 and the base on the exponential cancel each other out, leaving us like so, and then we will subtract. Now I'm going to introduce something right here. Okay, that is not incorrect, but it is potentially a little bit ambiguous, because somebody will wonder whether or not we're supposed to subtract the 11 minus 3 and take the log of 8. And we do not want to do that, because if you look at the original problem there, we were taking log base 3 of 11, and then we're subtracting 3 from the result of that. And so what a lot of people will do in that situation is, instead of doing minus 3, they'll actually add the negative 3 to the other side. And this is, again, where that position versus operation thing comes into play. It doesn't matter whether the negative 3 is on the left of the log or the right of the log. The important thing is that you are subtracting it, or that it is a negative 3. So you're either taking away the 3 with subtraction, or you're adding a negative, which are the same thing. That's the important thing, not whether or not it's on the left or the right. And people will do that to avoid the ambiguity of, did we mean to put that in parentheses? Maybe we didn't mean to. Like, what should I do? If we just put the negative 3 out front, nobody's going to question it. Now, that right there is the exact answer. Okay. If you are cleared to approximate it, you would go grab your calculator and get a decimal value for that. So we would have x is equal to negative 3 plus 2.183. And that would be negative, negative 3. Like I said, I'm using a calculator that I do not normally use. 1.8 All right. I am getting a really weird answer here. Hang on for a moment. Okay. I mentioned I was working on a calculator that I don't usually use, and it started throwing me imaginary numbers. Really weird. So I ended up actually having to do the problem like backwards. Anyway, so we end up with negative 0.817. And my apologies for that. Well, first I didn't put a ANS where I needed one, but then yeah, I started getting stuff with imaginary numbers in it. So I had to take a moment and sort that out. But there you go. All right. So and then that would be my approximate answer. So what does this solve, and what do we still need in terms of our exponential skills? This solves the issue of needing to undo an exponential of any base. So it sets us free from having to match up bases. So any kind of base, we are like good to go. So you could see, 5.3 to the x plus 1 equals 6. And we now have a tool that can get us to where we want to go with the x. This does not solve the issue of possibly having more than one base. Now, to be totally clear, in real life situations, you would rarely see an equation that looks like this. So this would be like 3 to the x plus 1 equals 4 to the 2x. Now what do you do? Because you cannot write those as powers of each other or of a common smaller number, and also they don't have matching bases, so they're not going to have matching logs either. What would you do? Now, I am planning to make a video in a little bit. We got to cover some other stuff in our toolbox. So as it says here, we still need more tools in our toolbox because we don't at present in this lesson sequence have a tool that will handle that for us. But realistically, if you're worried about like, am I going to see stuff like that in my engineering or my science classes? Probably not, because in nature, we kind of pick a base and stay with it. But we do have a couple more things to cover along those lines. So please don't forget to like this video if you found it helpful, subscribe to the channel so you don't miss any new math videos, drop a comment to ask a question, to engage, to, well, if you're gonna read me out for having a calculator issue, just, try to be gracious about it, and check out the practice set for this lesson. I will be sure to link that below so that you have a chance to test your knowledge on this material. I hope to see you in a future video.